Hello everyone, so this is Parvez and today we will discuss about rotational motion, right? So actually in rotational motion I want to discuss about moment of inertia, right? So first I want to write here what is the moment of inertia, right? So this is a moment of inertia. This is short term, right? This is moment of inertia, right? So, what is the definition of moment of inertia? I want to write here first. So, note down all of you. What is moment of inertia? The product of the product of the product of mass of a body, the product of mass of a body, and the product of mass of a body and square of perpendicular distance, square of perpendicular distance, square of perpendicular distance between body between body and rotation of axis, otherwise you can write here axis of rotation, axis of rotation. See first I want to draw here this is axis of rotation and one particle is present here. Suppose mass of this particle is m and now this distance will suppose r1, right? So this is the axis of rotation. About this axis your particle is moving continuously. So what is the moment of inertia of this particle? So moment of inertia you can write means my in short, and moment of inertia equals to m into r square. Okay, m. What is m? Mass of this given particle, mass of this given particle. Okay, and next what is r? R is c. R is the perpendicular distance from axis of rotation of this given particle. This is a perpendicular distance, right? Always perpendicular distance. Okay, this is moment of inertia. And see, this moment of inertia is means tell me, is this a vector or a scalar quantity? Yes, this is a scalar quantity. It doesn't depend on direction, right? So moment of inertia, it is a scalar quantity, and the unit of this moment of inertia will be kg. See, what is the unit of mass? Kg. And what is the unit of this distance square? This is nothing but m square. So kg meter square. Okay. So after first note down all of you. After that I will discuss about means there are different types of moment of inertia in physics, right? So first see, I think all of you see, suppose in a linear motion, okay, there are two types of motion generally. First is linear motion, and second is means it is called you can write rotational motion, or means you can write here means angular, okay, angular motion or rotational motion, right? See all of you. So what is a linear? See, suppose your particle is moving, so you can write here s. S is displacement in case of linear motion. So analogy means equivalent of s in case of angular is theta. It means your particle is moving in means linear displacement, suppose s. So in case of angular displacement will be theta. Suppose your particle is moving in a linear motion, okay, and suppose your particle has velocity u in this linear motion. So what will be the means velocity in means like angular motion? It will be omega, right? And suppose your particle is moving and acceleration is a. This acceleration is in linear motion. So what is the direction? Means what is the notation? What is the sign of acceleration in angular motion? This will be alpha, right? So here displacement, the analogy of displacement is theta, analogy of u is omega, analogy of acceleration is alpha, sorry, right? And next suppose your particle is moving along means in the axis means along linearly, okay, means your particle is moving linearly, so this force we have to use, right? So in case of linear motion we have to use force, and you know what is analogy of force in case of angular motion? This will be torque. Means the role of force in linear motion is same as the role of torque in angular, means you can write here rotational motion also, it will be better, right? Rotational motion, okay. And see, tell me all of you, suppose I want to write here, see, suppose one thing, this is axis of rotation, right? And one particle is present here, and now this axis is r, distance of axis from this particle is r, and this is always you know perpendicular axis, right? Now your particle is moving, okay, your particle is moving along this axis, okay. This particle is present in plane, in board of plane. This particle is present in board of plane. Now one force is acting, one force is acting. See, one force is acting on this particle. So due to force, your particle will be accelerate. So I want to write here, due to force, mass into expression will be occur here, because one force is present and this will be perpendicular, right? So due to this force, your particle will accelerate. So F equals to mv, right? So you know this is equation, okay? I think Newton's second law. So can we multiply both sides with r? So see, multiply by r. R is nothing but distance, perpendicular distance, both side, okay? You will get here rf, and here you will get m into a into r, right? See, tell me what is acceleration? You know in circular motion a equals to r alpha, right? So this is actually tangential acceleration. So rf equals to mass into 8, and you know what is tangential acceleration? R alpha. You can write here R alpha into r. So rf equals to m r square into alpha, okay. And what is this rf? This will be torque. Torque equals to, you know what is mr square? This will be moment of inertia into alpha. So see, I have already told you initially I have taken here mass force equals to mass A, and finally I will get here torque equals to I into alpha. So in linear motion the role of F is same as the role of torque, and in linear motion the role of acceleration is same as the role of alpha in case of means rotational motion, and yes, the role of mass in case of linear motion is same as the role of moment of inertia in case of means I. Means suppose your object is moving and your object has mass m, and you want to calculation in case of linear motion. So function of m is same as in the function of I, okay. So there are means various problem based on this moment of inertia, okay. And no, in rotational point of view, otherwise in physics also, there are two types of particle generally. First is the point mass, and second is discrete, means continuous, like, okay. So first I want to write here, see, calculation of moment of inertia, okay. So see, there are two types of particle present in this world actually, okay. Generally, first is point mass, and second is continuous mass, okay, continuous mass. So see, suppose the one particle is present here, this point mass, and it has mass m, and now this is the distance r, right? And now this is axis of rotation, and about this axis your particle will move, your particle will rotate. So what is moment of inertia of this particle? Moment of inertia of this particle will be m into r square, and always you know r is perpendicular distance, right? Because I want to tell you, see, suppose one particle, suppose this is a string length L, right? And this angle is 60, right? This is string, right? And this is axis. Now your particle is present here, and now your particle is moving along this axis of rotation. Then what is moment of inertia? Is moment of inertia is mr square? No, because always we have to take perpendicular distance, and this is the perpendicular distance in this case. And perpendicular distance will be, see, if this is r, okay, if this is r, okay, this will be r cos 60 and this will be r sin 60. So this length will be r sin 60. So you can write here moment of inertia equals to mass into perpendicular distance from axis of given axis from particle. This will be r sin 60 whole square. This will be m into r square sin square 60. Finally you will get m into r square into root 3 by 2 whole square. Finally you will get moment of inertia equals to m into r square 3 by 4. Finally you can write here 3 by 4 m r square. Okay, thank you.